Cool, welcome back. So, next one, square digit sequence. Let's take a look at it. We'll see what it's asking us. Okay, so we want to consider a sequence of numbers, A0 or A0 to AN, in which an element is equal to the sum of square digits of the previous element. Okay, and we'll get a visual example of what that looks like in just a sec. The sequence ends once an element that has already been in the sequence appears again. Given the first element, A0, find the length of the sequence. Okay, so they give an example over here. We've got 16, and they're saying the sequence is going to be of length 9. The reason we say it's 9 is because we start with 16, we square its digits, add them together, or add the results together after squaring them. So we get 1 squared plus 6 squared, that's 1 plus 36, so we get 37. And we haven't seen 37 before, so we square the digits. 3 squared plus 7 squared, we get 58. 5 squared plus 8 squared, 89. We keep this going until we find one that we've seen already. So finally we get down to 16, and we say, hey, we know that one. We've seen that one already. So we're good. We can stop there. Okay, so that's basically the idea. We want to say, how long did it take? This one took 9 steps in total. Okay, this one over here, we've got 103. Following this set of steps here, we'd have 103, then 10, then 1, then 1. Sorry, I thought 4 was going to be in the sequence as well. So that ended kind of abruptly. But anyway, yeah, it ends at 1. We've already seen that one. Okay, cool. Great. Makes sense. Nice stuff. Let's get it done. So how are we going to do this? Is this going to be a nested loop situation? We'll find out, I guess. I think what I want to do before we go any further, just because I have a feeling we're going to have to do this at some point, is let's write a function which is going to be digit square sum. Yeah, for a number. And it's basically just going to return the sum of the squares of the digits. Okay, so we're going to start out with this thing sum. It's going to be sum the value of 0. And it's the thing we're going to be returning at the end of all this. What are we going to do with this? We're going to say while num. Okay, so while the number exists, right? We're going to say const digit. And this is something we've done a few times before, but let me know if anyone has any questions, comments, or concerns about this. Sum is going to be the square of the digit, so we'll just do this. And then we want to say that the number is going to be reassigned a value of math.floor of num divided by 10, which is basically just truncating off the last digit. We'll keep this going until there's no number left, and then we're going to return the sum at the end of that. So that's our digit square sum. And, you know, this does have a loop in it, so it might not look like we're going to have a nested loop, but it could be a bit deceptive. If it's a loop where inside we're calling digit square sum, then yeah, technically that's a nested loop. Okay, so let's continue. What do we want to be doing here? Well, basically, okay, we'll do something like this. We'll say let, or const, seen, something like that, visited, already seen. Yeah. Already seen these. Yeah, let's do that. And it's just going to start with A0 in it because we've already seen that. All right, and then what do we want to do with this? So we'll do something like this. While true. So we're going to live dangerously with an infinite loop here. What are we going to do within the loop, though? So basically, we'll say, yeah, I mean, I guess we'd just modify A0. I was just about to say, like, you know, let num be assigned the value of A0 or A0. But I guess we could just use it itself, right? So we could just say something like this. It's assigned the value of its own digit square sum. And then if we've already seen these, or yeah, if I've already seen these, that includes this new value of A0, then we're gonna stop it there. Yeah. break. Else, then we'll add it to this. So we'll push it in. Yeah. And I'm already thinking maybe this should be a set instead of an array. Yeah. Because order's not going to matter here, right? We're not going to have to like remove any elements after encountering them. So, and yeah, and we don't need to know the order. So I think it's totally fine to use a set here. So instead of includes, now we can say has. Instead of push, we can say add. Oh, it's just a lot nicer. I like that. Okay, but then there's one thing I forgot to do, which is that we actually want to count the number of steps here. So sequence length, just to use the vocabulary of the question over here, right? So what do we want to be doing? Increasing the sequence length at the end, I guess, right? Yeah. And then just return the sequence length. Okay. So let's just tighten this up a little bit. Maybe try to, yeah, I can't quite see all of it there, but I think we can see the parts that matter. Let's run the tests on this. We'll see what happens. Ooh, okay. So we're getting 8 instead of 9. We're getting 3 instead of 4. We're getting 1 instead of 2. Folks, I think I'm seeing a pattern here. So let's see. Hold on a minute here. If we're looking at this, and this one is considered a sequence of length 4, that includes the one that's repeating. So there are two ways we could deal with that. We could either put the sequence length ++ up top here before the break, or we could just start it at 2, because it's not like we're going to have a sequence that's less than 1, right? Like, even if it was just 1, 1, that's of length 2, right? So it has to be at least 2. I think it makes sense to start it at 2. Let's run the tests. Yeah, that's working. Okay, let's run that. Cool. It worked. All right, nice job. We did it. So we'll close that, and what do we want to do now? Well, I'm mostly happy with this one. I think it's pretty good. I mean, it's got the nested loops, but I like our usage of like the set over here. I think that's pretty smart. I'm thinking there's probably another way we could do this. Yeah, actually, there are a few other ways we could do it, but okay. Specifically, the way I want to do it next is going to be a little sneaky. Yeah, it's going to be kind of interesting though. So let's get rid of that and then paste it back in. I am going to reuse part of the code down here. I think we'll just keep this one the same. No need to switch it up. It's a good one. Yeah, it's good. Okay, cool. So here's what I want to do. Let's say const sums. Yeah, sums. It's going to be assigned the value of Array.from length 651 with a second argument that takes the element and its index to digit square sum of the index. Yeah, cool. That's sums. So you might have a few questions about that. First, 651, what's that all about? It's about this. So check it out. A0 could be anywhere between 1 and 650. So I'm doing 651 because the I here is starting at 0, and this needs to include 650. So I'm just adding on that extra 1. Okay, so look at this. This is all of our digit sums. Now, you might also be wondering, well, like, how are you so sure? Like, how do you know we're not going to need, even though the first term starts at 650, how do you know we're not going to need, like, something in the 700s or, like, in the thousands or something later on, right? Like, what if it increases? Well, let's think about that for a minute. The largest possible 3-digit number we could come up with is 999. Not only is that the largest possible, but it's the one with the largest digit square sum. Okay, so basically the idea is that the digit square sum of 999 would be what? 9 squared plus 9 squared plus 9 squared. So what's that? 243. Well, that's a lot less than 999. So like we basically reach a point where these start to only decrease the numbers. Like there's a certain point where they're no longer going to increase. And I am actually curious, like I don't know if there's a proof of whether or not these can have any infinite like loops kind of thing, cycles, I guess is the word I'm looking for, where they could just sort of bounce back and forth or something like that. I don't know. I haven't really thought of any. Well, hold on. I mean, technically, yeah, I guess there would be. Okay, so something like this, it's just going to repeat and repeat. For something like this, that would be a cycle that would keep going on forever. So yeah, silly me. That's the whole point of this, I guess. I guess it has to happen eventually. Okay, so here we go. What have we got? We've got, yeah, all of our sums here, all of our digit sums. And you might be wondering, like, well, why don't you just put in I plus 1? Like, do you really need 0 there? I could have just put in I plus 1, but there's a reason I didn't. And it's basically going to be the following. So these are our sums. Why do we want these? Well, we're going to do something really similar to what we had down here. We're going to do the same sort of thing. So the main difference is, actually, hold on. Let me just grab this and then we'll carve out the differences from there. So we're going to have sequence length, just like we had before. We know it's going to be at least 2, but the way we're going to deal with this is going to be a bit different. So instead of saying, already seen these, instead of doing that, we're going to basically punch out the sum. Okay, so what do I mean by that? Well, first of all, let's not return the sums. Let's do this. So we've got sums. I want to say sums at A0. It's equal to 0. Whoa, geez. Okay, you don't see that too often. Well, we don't see it really anywhere except for 0. I mean, it wouldn't make sense, right? If we're squaring the digits, like the only way we could square the digits, add them up, and get 0 is if they're all 0. So yeah, that's the only way that could happen. Okay, so we're going to set these to 0. Why are we going to do that? Well, basically, this is the reason. So first of all, we don't actually have to call digit square sum here anymore. We're just going to do sums at at A0. Yeah, cool. There we go. Sums at A0. Yeah. And then instead of this, we would just say if A0. Or actually, if not A0, then break. Because if we've already seen it, then we've already set it to 0, just like we did up here. And I guess with that in mind, let's set it to 0. So we'll say sums at A0, which is going to be like the next one. Wait, hold on a minute. We need to do that before moving on. Yeah. So we'll say let next be sums at A0. Yeah. And then sums at A0 is going to be assigned the value of 0. And then this one is going to be assigned the value of next. Yeah. I'm wondering if we could use like a destructuring assignment for that. I'm not really sure. We'll get it working first, and then we'll worry about that after. Okay, sequence length plus plus. We don't need to worry about that. Return sequence length. Do we have everything we need here? No. Okay, what's wrong with it? Let's find out. So we've got our sums over here. Sums at A0 is going to be 0 to begin with. Let sequence length be assigned the value of 2. We're going to be increasing that while true, and it's only going to break if A0 becomes 0 at some point. And so I guess what's happening is that it's becoming 0 earlier than anticipated. Maybe what we'll do is right before the return, let's just do a little console log of sums. Let's see what that's looking like when we actually return it. So, okay, we've got a 0 here. I'm guessing that's at the 16. Yeah, I think that's at the 16. So that's good, right? That's what we want. Well, we started with that. So then we should also have one at the 37. I guess it's a bit hard to tell where that's going to be. Maybe here, let's not just console log sums. Do sums.map. x and I gets mapped to x and I. Or actually the reverse, I and x. Yeah, that'd probably be better. Okay, cool. So yeah, 16 was 0, 37. Oh, not 0? Well, why not? Okay, hold on. What's going on here? So A0 starts as 16, right? And then, so we say let next be assigned the value of sums at A0. So that's going to be whatever we have at 16 here. Oh, it's 0. Yeah, we already set that to 0. Okay. Well, should I just not do that then? Like, do we not need that over there? Is that sort of what I'm seeing here? Yeah. Yeah, because it's only setting it to 0 as it's like moving away from it. I think that's probably good. That probably makes more sense. And now that's 1 too big. That's 1 too big. That's 1 too big. Okay. It's probably because we're starting this at 2, and now it should probably be 1. Yeah, because we're checking to see if A0 has already been set to 0. So, like we would have already done the next and then incremented this one more time than in the previous one. Okay, cool. So, yeah, this is working now, right? Great, great. But here's the thing. Or here, let's just return sums for a minute. We'll run that. Here's the thing. This data here, like this big array, it's got a lot of numbers in it, but they're not going to change. Like these are going to be the same no matter what, right? Well, I'm generating these, like right now, I'm generating them from this. I'm doing my Array.from. I'm calling digit square sum. But like I'm always going to generate these same numbers. So as long as we only need to deal with numbers as big as 650, then this is probably good enough. And in fact, because this was the only time, generating this was the only time I was actually calling digit square sum, I actually don't need that anymore. So this is a bit massive up here, but in terms of computation time, I think it'd probably be faster. It doesn't have to call a function each time. It's got to keep this big array, I suppose, but yeah, I don't know how much of a memory requirement that's going to be. Anyway, that's kind of a neat way of doing it. I think that's cool. For this part over here, well, actually, hold on. Let's run the test again. And, oh, am I returning sums still? Well, look at that. The code's even shorter than I thought. Let's run this. Okay, cool. Nice job. Okay. So what was it? Yeah, it was just this thing over here. I was thinking maybe there's a way we could change that. I'm not sure if this is going to be possible, but we'll try it. So we'll say sums at A0 and A0 are going to be assigned the values of 0 and sums at A0. Yeah. So does that work? Oh, well, that's even nicer. Okay, I like that better. Yeah, that's good. Good. Very good. You did it. Congratulations. Okay. Have you guys noticed these, by the way? The sort of new avatars instead of that, like, old symbol. What was it? It was like this or something. Anyway, I think that's cool. This app just, it keeps getting better and better. Anyway, okay, so is that going to be it for this one? I don't know, maybe there's a better way we could do this. Like, I'm not really sure. I was going to say maybe we could use an object or something like that, but this is kind of doing that already. Like, it's kind of doing the work of what we would normally use an object for, in the sense that, like, the indices that each of these numbers have are actually very, very meaningful here. It's basically the number that would give us this square digit sum. So, yeah, so I don't think an object would be any better than what we have here already. Okay, cool. Well, I guess that's going to be it for this one. Yeah, we submitted everything, right? Yeah, okay. Let me know if you have any questions, comments, or concerns. We'll pop out of here for now. And, yeah, I think that's going to be it for today.